So welcome everyone. Before we start, my only pre-announcement is just to introduce Eduardo Neto to you. Eduardo is a graduate of this program, finished in what year?
86.
86, cohort 4. He's here visiting from Brazil, bringing the genius of Stanford and Berkeley data science connections to social science back to Brazil. You're on a mission, kind of a discovery mission here, but he's also visiting the department for a couple of days. So welcome, Eduardo, and I hope you get to meet our new cohort of students.
And Eduardo is responsible for sending us a huge string of distinguished and successful students over the years, as we hope when all of you graduate and go on, you will do too.
Yeah, that's
it's a stayer of
DNA community. So welcome. Today we have another in our series of wonderful in-house speakers. So Dennis kindly agreed to give a talk early in the year, so thank you, Dennis. I'm not going to do a long introduction of Dennis, which wouldn't be worthy. When Danny introduced me, I rose with tears in my eyes, so I have nothing like that for Dennis. But just to let you know a little bit of his multiple strands, he was going to present on his work using network estimates of mortality, but instead he is going to present a different topic. When we recruited Dennis to come here, he presented a paper that had some of the formal ideas behind the paper he was going to present. And there was a big negotiation about how soon can you come, Dennis? We need you. He said, well, I really want to do a postdoc at Facebook. So I worked with him to allow him to do that, but to do it very quickly. So this is a continuing work from that, and we're just delighted that you agreed to give this talk, and especially to choose this topic, which I think is probably of general interest to people getting involved with these new types of data sources. So,
great.
Thanks, Dennis.
Thanks, Josh. Thanks everybody for coming. Thank you. So I'm going to be talking today about how to use one way that you can use an online sample to learn about an offline population, and this is something I've been working on in collaboration with Curtis Cobb. And so I thought I'd start by kind of trying to describe in very general terms the problem that we're thinking about, and then I'll get a little more specific after a couple slides. So I think this is a situation that probably most of us have come across. We're interested in studying some particular population that's interesting to us, and what we'd really like to be able to do is to interview a sample of people who are in this population. Ideally, we'd interview everybody, but practically speaking, we'd like to be able to take a random sample of this population and talk to folks who are in it, so we can make inferences about the entire population. There's a lot that's understood about how to do that, and so it's something that we can certainly do, but it can be very time-consuming and expensive to do that. Obtaining a high-quality probability sample is quite difficult, and it can take months, if not years, to produce a data set and an estimate from that approach. But it might be the case that there's another group that's related to this population that we're interested in, but that's not quite the same. So I'm thinking about, for example, people who use the internet, people who have mobile phones, people who use a particular website, or something like that. And so it might be the case that it's quite a bit easier and faster to get a hold of folks in this group, but the problem is that this group is not the same as the group that we're really interested in learning about. And so what I'm going to talk about today is one approach to trying to use information from a group like this to learn about a broader population. And in particular, just to kind of give you some framing for where we're going, the idea is going to be that you can sample people who are in this group, and you can ask them about the people that they're connected to through different kinds of in-person social networks. And those reports will have information both about people who are in this group, but also about people who are not necessarily in this group. And so I'll go through some of the details in a second, but that's the general direction that this is going in. And so the specific topic that I'm going to be looking at today is trying to understand internet adoption around the world. So this is kind of the least demographic of the topics that I'm working on right now, but it has this kind of online-offline angle. So that's the trade-off at play here. So why is it important to understand internet adoption? Well, there's a lot of evidence that internet adoption can be very helpful to economic growth and development. But there's also a lot of evidence that there's inequality in who has access to the internet. In fact, some people would argue this is fast becoming kind of a main dimension of inequality in the modern world. Both within and between countries, it seems like there's a lot of inequality in who has access to the internet. This is a sufficiently important topic that this was the subject of the World Bank's annual World Development Report in 2016. And the United Nations Sustainable Development Goals have chosen as one of its indicators for tracking progress towards these goals the rate of internet adoption around the world. So this is something that's pretty important to try to understand. But I should say that the challenge is similar to the problem I outlined at the beginning, which is that to really understand internet adoption using traditional approaches, we need to conduct high-quality sample surveys all over the world, and that would be both quite expensive, and it would also take quite a long time. And in many settings, internet adoption seems to be changing on a very fast time scale. So if you're trying to understand what's going on and react to that, and it takes months and a lot of money to produce a survey estimate, well, that's not an ideal situation. So we'd like to try to be able to quickly estimate internet adoption cheaply. And so that's what we're going to talk about today. And so the general structure is that I'm going to talk a little bit about the methods, and then the study design, then I'll show you some actual empirical results, and I'll talk about where I think this kind of way of thinking about the online-offline problem can go in the future. So the methods we're going to use are arise from this network reporting framework, and as I mentioned, the general idea is to take advantage of the insight that survey respondents are connected to other people through lots of different kinds of in-person social networks. And so we can ask respondents questions about their personal networks and learn about more than just the respondent herself. And so this is an approach that has arisen. This idea is pretty natural, and it's come up in a lot of different literatures and a lot of different problems. So for example, it's been used to try and understand mortality and deaths, epidemiologically important groups like drug injectors and sex workers, people who migrate, and lots of others. And in the context of studying these different groups, there's a bunch of different methods that have been developed over quite a long time period. So multiplicity sampling, which I think is the earliest of these, was introduced in the 1970s, and then sort of the network scale-up method is something that's being worked on a lot right now. So there's a whole host of different approaches that try to take advantage of this insight that people have information about others that they're connected to in these networks. And so when I talk about the network reporting framework, I'm talking about a formal way to try and link all of these different approaches together. And this formal way has the advantage of helping us understand what these approaches have in common, how they differ from each other, and it can also be used to generate new approaches and new estimators based on network reports. And so I'll show you an example of generating a new estimator, or I'll show you some highlights of an example of that today. Okay, so that's the kind of big picture. The big picture is that we'd like to use these network reports to try and sample people online, but learn about people who are online and people who are offline. And so now I'm going to give you kind of a very simple toy example to illustrate the key points of how we derive the estimator in the paper. So this picture shows a population that has 6 people in it. I hope you can tell that four of these people are shaded in gray. These are people who are on the internet. And then 2 of these people have kind of blue borders, and those are folks who are also on Facebook. And this first picture depicts the social network. So there's a connection between 2 people in this network if they have a social relationship. So I'm going to talk a little bit more later about what these social relationships might be, but let's just say for now it's that they know each other. So person 3 and person 2 are connected because they know each other. So when we sample people on Facebook and ask them to report about members of their personal networks, we generate what I call a reporting network. And so in this reporting network, there's an arrow now, a directed arrow from one node to another when the person includes that other person in her reports. So for example, you can see here that person 2 includes person 6 in her reports. And so there'll be an arrow from person 2 to person 6. And the terminology that we use is that person 2 is making an out report to person 6, and person 6 is receiving an in report from person 2. So this turns out to be the kind of formal structure that has all of the information that we need to try and derive an estimator. But it's really helpful to rearrange this picture in the way that I'm depicting on the right here. And so this picture on the right has the same information, but it's drawn a little bit differently. So now all of the people on the left hand, all the people who are making reports are on the left-hand side here, and all of the people who could potentially be reported about are on the right-hand side here. And notice that, of course, people can both make reports and be reported about. And so this kind of structure is helpful because it makes it clear that every report that's made leaves the left-hand side and arrives at the right-hand side. And that means that we have a kind of population level identity, which says that the total number of out reports has got to be equal to the total number of in reports. Once we have this relationship, we can manipulate it a little bit. Algebraically, we can take the total number of in reports and decompose it into the average in reports per internet user, for example, times the number of internet users, and then we can derive an expression for the number of internet users. And so just to make that concrete here, you can see from this picture the total number of out reports about internet users would be 2. So this person contributes 2. This person contributes 2. 2 plus 2 is 4. And then the average, if you do the same kind of analysis for the average in reports per internet user, you would get an average of 1. So the estimate would be 4 over 1 is equal to 4. So the intuition here is that just adding up the total number of reported connections to internet users would produce a number that's too big because each internet user can potentially be reported more than once. And so to account for that fact, you have to adjust by the average number of times each internet user can be reported.
Can you go back one slide?
Yes.
How did you know about the 0 for 5?
So you don't have, so that's a great question. So this is often a concern. So what about internet users who wouldn't be reported by anybody? So, so an advantage of this framework is that we're just trying to estimate aggregate quantity. So if there are people who will never be reported, that will bring this average down. If we can't sort of somehow include those folks in the way that we estimate this, I mean, I'm going to talk a lot about how we estimate this visibility, but essentially what we care about is this population level average. So some zeros is not, if everybody is 0, that's a problem. If there are some people who are 0, that will bring this average number of times each internet user gets reported down, but it won't necessarily, it won't mean that this can't work at all.
So in your example, you divided by 4?
Adding 0. Yeah, there's 4. This is per internet user. There's 4 internet users.
2 and 3 count twice. They count as. I'm sorry.
There's 4 internet users.
Okay, you got the black.
This guy's reported once. This guy's reported once. This guy's reported twice.
Okay,
this
and
guy's reported
I'm
twice.
sorry. Why is it 2 plus 2? Where's the 2?
This person reports 2 internet users. This person reports 2 internet users.
Okay, got it.
Yeah.
So I guess what how did you know there were 4?
Is
How
not.
did you know
Well,
to
so
divide by 4?
I'm going to talk. Yeah, that's a great question. So I'm going to talk in a second about how. I mean, the whole next part of the talk is framed around how we estimate these two quantities.
Okay.
What I'm trying to convince you is that at the population
know.
levels, this is So that's a great. Actually, what that illustrates is that this is a framework that tells you that gives you something that you need to then figure out how to try to measure. Okay. And so we're going to organize the discussion around the study design around this identity. Because what this example reveals is that in order to estimate the number of internet users from these reports, we have to figure out how we're going to estimate the total number of connections to internet users and how we're going to estimate the average number of times each internet user gets connected. Sorry, gets reported. So I'm going to talk about that in a second. I'm going to start by talking about this numerator. So how can we estimate the total number of reported connections to internet users? Well, we can ask the survey respondents questions like how many people are in your network, and then which of these people uses the internet.
So, I'm sorry, the first question, that's the digital network, or that's just the
This is
social
the real world social network.
And do you give them a definition of network?
Yeah, I'm going to talk a lot about that in a second. Yeah, exactly. So what does it mean to know somebody? What's the definition of the network that we're going to use? Well, that's a great question, and in fact, that is a really important study design parameter. So when you're trying to design a survey to use network reports to measure something, which network specifically you're asking people to report about is a really critical question. And so this is something some of you have seen before, but as part of my dissertation, I developed this kind of framework that is a theory, it's a conjecture, it's not, it hasn't been empirically proven, but it's a way to think about what trade-offs might be at play when we ask about different types of networks with this approach. So I'm going to try to think about this in terms of how strong the tie is in a sociological sense. So what that means is that a strong tie is a very meaningful, intense relationship that probably, but not necessarily, involves a lot of frequent interactions. And a weak tie is something like an acquaintance or somebody you happen to know but aren't deeply involved with, and you can imagine that there's a kind of spectrum in between the strong, all along this dimension. So there's all sorts of different types of networks that people are in, and those relationships are characterized by a strength of the tie. So if we think about what trade-offs might be at play when we pick a stronger or a weaker tie, one issue that comes up is that it's a very regular finding in social networks that relatively strong tie networks are pretty small. So meaning that people are connected to a relatively small number of other people through strong tie definitions. On the other hand, relatively weak tie networks are pretty big usually. So that means that the sampling error we would predict will go down as we ask about weaker and weaker ties, because the intuition is that we obtain information about more and more people as we ask about these weaker types of relationships. On the other hand, we think that people will be able to provide much more accurate information. They'll know a lot more about other people who they're connected to through a strong type of network connection, as opposed to people who they're connected to through some kind of weak type of network connection. And so combined, these two different, these predictions kind of work in the opposite direction, and that suggests that the total error, which is what we care about when we're trying to use reports to measure something, may be minimized at some kind of intermediate type of tie strength. So this is one way to think about the trade-offs that might be at play as we try different kinds of networks when we ask these questions on the survey. And so some previous work has found kind of preliminary evidence that there may be a trade-off between the quantity and the quality of information that comes from these network reports. And so we designed an experiment and embedded it in the survey that I'll tell you about that kind of further tested this question in this really pretty different setting. And so that experiment randomized people who responded to the survey to report about one of two different types of personal network. So this first network asked, how many people did you have conversational contact with yesterday? And so this is a question that came originally from the epidemiology literature. Epidemiologists have used a question very similar to this to try and understand the rate at which people have some kind of contact with each other for the purposes of modeling infectious disease. And we thought that this would be a pretty weak type of network connection, meaning that we think that these numbers will be relatively high, but that people won't necessarily have a lot of detailed information about other people who they're connected to in this conversational contact way. Okay, so then the other possibility, the other network that people were randomized to possibly respond to is a version of the relationship that I've studied in previous work in Rwanda. And here the question is, how many people did you share food or drink with yesterday? And so this is the idea here is that this is we expect that this will be a stronger, more socially meaningful relationship, and so we think that the size of people's networks will be smaller, but that perhaps the information that they have about others will be more accurate. Yes?
I'm curious if your previous slide with the, yes, should we interpret this as like a Laffer curve where like by rule there will always be sort of intermediate tie, or are there some questions that really the strongest tie you can possibly get is the one that you should care about, so much so that like you should probably only report on yourself?
Great question. Great question. So this is a conjecture. So a couple things. So this is closely inspired by what's called the bias-variance trade-off in statistics. So the idea here is that there'll be more. The sampling error is essentially sampling variance, and this non-sampling error would translate into bias, correctly speaking. And so, but let me emphasize that these are conjectures. This is a relationship that I think is quite plausible from the social networks literature, and the study I mentioned earlier in Rwanda found some evidence that there may be quantity-quality trade-off, but I'll talk about this a little bit more at the end. We don't know really what the shape of these relationships is, and it would be pretty powerful to be able to understand that, because that would let us understand before we collect any data what kind of relationship might be most appropriate for learning about whatever we want to learn about in the setting. So it's a good question. I don't want to say that this is a mechanical, so it's mechanically true that if the shape of these relationships is right, then yes, there is some intermediate type of and there is a tie at every point in this continuum, then there's some intermediate value at which the total error will be minimized, but I can't, this is more of a conceptual kind of way to think about this. Yeah. Thank you. Okay. Okay, great. So I'm going to kind of keep describing the study design, and I'm just going to use this meal network for to have a concrete example as we talk about this. But for the whole approach here, respondents were randomized into one of these two different networks. So everywhere you see meal, you could also think conversational contact. Okay, so we can ask the survey respondents a question like, how many people did you share food or drink with yesterday? And let's suppose that the respondent says, a particular respondent says 6. I shared a meal or drink with 6 people yesterday. So what we'd really like to know now is the proportion of the respondent's network that uses the internet. And so ideally we'd go through each of these people. The respondent has in her network and say, do you think this person uses it? But that seemed likely to cause unacceptable levels of respondent fatigue, particularly because this survey is being administered online or on the cell phone, and so it's not something that respondents are going to have the patience to do.
But in
Yeah.
the case if this question were asked for any of us,
Yeah.
then we would all have to reply 38. Is that right? That's the way the question is.
That's a great question. So we did a little bit of pilot testing of this in Rwanda, and there are some edge cases where it may be unclear to the respondent what meal means. And because we delivered this survey like on the internet, we didn't have an interviewer who could help walk through it. So basically, that's just going to contribute to error in this case. I mean, this is like an approximate approach. But it's a very good point. It's harder than you might think to come up with these tie definitions to ask people about, but yeah, I acknowledge that there's probably some ambiguity in how respondents interpreted this question. It's a fair point. Yes?
So I'm not understanding your answer. I mean, isn't the answer 38? That's not ambiguous. That's a fact.
Well, so they
It's
could
just a
report...
larger number, larger than you may have expected, but it's
Yeah.
not wrong.
Right, so we'll allow them to report 38. They can report up to 99 in the survey form. I'll show you in a second when I analyze it, I'm going to top code the numbers above 30. Well, I'll show you in a second some actual degree distributions, but yeah, so people could report 38 if they knew it was 38. The problem is that once the actual, well, this is again something that there's some evidence to support, but we don't know for sure. But it seems plausible that once people's number of network connections gets bigger, they start to estimate instead of counting how many people are in their network, and so that can lead to error. Not clear that error biases things, but at the very least it adds noise.
Not clear what sharing means either, for that matter.
For sharing food or drink?
Yeah.
Yeah,
Does it mean eating together, or does it mean eating out of the common boxes?
Yeah, so we try to provide some understanding of this with the word. So the wording here came from an in-person interview that was done in a previous study that we adapted to the data for here. But so just to read all of it, we say these people could be family members, friends, coworkers, neighbors, or other people, food or drink at any location, including home, at work, a cafe, or a restaurant. So.
Not clear to me.
Okay, well, so then that would predict, if you think that's really unclear, that would predict that we would get noisy responses from the meal network, and that do you think this is clearer?
Yeah.
Okay, so then let's keep
What's
that
unclear there is if I have more, does it mean others have less? If it doesn't mean that, we're not sharing.
Oh, so it was specifically the word share that you...
Yeah.
I see. Okay, that's a great point.
Is that a colloquialism? I mean, is that specific to the national context? Like here we might say, how many people did you eat with yesterday?
Yeah.
Maybe in the countries you're surveying, share a meal has that meaning.
Yeah, I mean,
Yeah.
these instruments, as you'll see, I'm going to show you data from 5 countries. 2 of the countries speak English, 3 of them don't, and so the instrument was translated, back translated, and so forth. So it's also going to be
Particular
translated.
wording,
So
probably.
the concept we're trying to get here is sitting down to have a meal with.
Yeah.
It's an interesting point to specifically object to share, but yeah. Let me point out though, that makes the prediction that the responses to this meal network will be all over the place, and to foreshadow things, that's not what we're going to see. Yes?
So I guess the tenor of the response I'm hearing is that there may be some mistake. but I don't really get its mistake because it says explicitly food or drink,
Yeah,
which drink is much, I'm having coffee.
yeah.
And so I guess it's sort of like the deployment of this question. Respondents sound like they're actually listening to the question,
Yeah,
but they're listening to the question, which allows them to be clear about what they need to answer,
uh-huh.
doesn't jive with what this particular deployment needs to be the question. So it's not really a problem with the respondents
Uh-huh.
not understanding what a meal is.
It's
The problem is coming from the deployment of a question
Mhm.
in a context for a purpose that it was not designed.
I see. That's a good point. I mean, we don't need them to, so this is kind of instrumental in the sense that we're going to use the information that's generated by this question to try and estimate internet adoption. So if everybody, what I would worry about is variance among respondents and how they understand what the question means. Not if they understand it differently from how we design the question to be understood, that's actually not, maybe this is the point you're making in part, that's not necessarily a problem. But if there's a lot of variation in like who understands the question in which way, then that would be a problem. Yes.
Is it a problem if there's network heterogeneity on how strong these ties are, right? So for some people, maybe a conversational content network is a stronger tie than
Yeah.
a neural network and vice versa.
That's a good question.
Is it just sort of central tendency that we're worried about, or is individual heterogeneity really a problem?
For the purposes of the conjecture/theory that I'm describing, the central tendency is what we're interested in. But it's a good point that at an individual to individual level, there almost certainly is variation in how strong these ties are. So the idea is that this is supposed to be on average a stronger type of network. Again, we'll see some results that suggest that might be true, but yeah. And let me, yeah, okay, so, great. Okay. Okay, so what we're going to do is, so we'd like to understand this, ideally we'd ask the respondent about every single person that she reports being connected to, but that seems like that would cause a lot of respondent fatigue, and so we think that respondents would just stop taking the survey, and that's not worth, that's not what we want to happen, so we ask them to choose 3 people who come to mind first to provide more detailed information. We call these people the detailed alters, and we're going to treat them as a sample of the members of the respondent's network. And so this is an approximation. So in reality, what's probably going to happen is that some alters, which is the people the respondent is connected to, are more likely to come to mind than others. And so we can kind of get at this challenge in 2 different ways. The paper has a sensitivity framework that describes sort of mathematically exactly what will happen if if respondents tend to refer one type of respondent more than others. And we can, as I'll show you, I think we can also check this empirically. So I'll show you in a second that we can do some analysis of the data that we're going to collect that lets us get some sense of whether or not this condition appears to be satisfied, and sometimes it is, and sometimes it isn't. Is the result that we seem to find. Okay, so that was that's how we're going to estimate this numerator. Now let's talk for a second about how we can try to estimate this denominator, which is always the hardest part of trying to produce information like this. And so you can imagine a lot of different approaches. You can try to build a model that will predict the average visibility of people who use the internet. As I'll talk about in the end, you can actually try to measure this directly, but not from a sample only of people who are on Facebook. And so what we're going to do is we're going to take a very simple approach. We're going to assume that people don't pay attention to whether or not they're on Facebook when they share meals with one another. Okay, so that would be violated if people, for example, organize sharing meals together using Facebook. So if they have a Facebook group where they say, we're going to go to lunch, we're going to all go to lunch together, and people who aren't in the Facebook group don't have access to that. But otherwise, it's okay if these people share meals at different rates in general, but the idea is that behaviorally, the idea is that people aren't using Facebook to make the decision about whether or not to share a meal together. Yes?
Give an example of a Facebook group, but I mean someone could invite someone to a meal over Messenger.
Yes, so, right, so if you go to a lot of meals by inviting people over Messenger, and that causes you to not go to meals with other people, then that would mean that this condition was violated, yeah. So, it's possible. And again, this is, and so we can estimate the second quantity from our survey responses, and again, this is something that we're going to be able to look at empirically. Okay, so why don't I move on to the, okay, let me just quickly recap, and then I'll move on to the empirical analysis. So, so the three key conditions that these approximate estimates are going to rely upon are, first, this idea that the detailed alters are picked at random. Second, that people don't pay attention to whether or not they're on Facebook when they decide to share meals or not share meals together. And then third, that reporting is accurate. I actually put a star here because the sensitivity framework reveals that we don't really need the reporting to be accurate. We need the reporting to be similarly accurate for the numerator and for the denominator. So in other words, a lot of these network reporting-based estimates have this structure that what matters is a correlation between the thing that you're interested in and the reporting error, not actually reporting error per se. Yes?
What I was getting at, I guess, was an inversion of this question. So
Yeah.
does it matter whether or not people who share news together join Facebook and become friends and then start messaging? You know, does that matter?
If people who are
People who have
Operate.
news together then join Facebook or become Facebook friends.
So if those people then don't, I mean, it would matter if then after becoming, so if they're friends and they join Facebook together and then they only have meals with each other and they start to exclude having meals with people who aren't on Facebook, then that would be a problem. So all we care about is this population level quantity, the average number of meals a Facebook person shares with another Facebook person, and the average number of meals that somebody who's on the internet shares with a Facebook person.
But I guess that number could go up for somebody who has the same pool of friends as they have more lunches and find out people on Facebook. It looks like they're intensifying the strength of their connection of their Facebook network, I guess.
But I think what you're describing would affect the numerator and the denominator of the average. It would increase the number of people on Facebook and also the number of people who share meals on Facebook. So again, like what matters is here. What matters is these two rates. So the rate at which people who are on the internet share meals with somebody who's on Facebook, and the rate at which people who are on Facebook, the rate at which people who are on Facebook share meals with somebody else who's on Facebook. So I think the phenomenon you're describing will drive the denominator and the numerator up here. Yeah.
So I see that you're about halfway through your slides. So let's hold off for a few minutes, let Dennis make some progress, and then we can come back in and be interactive.
Okay. So let me talk a little bit about the empirical results here. So we have a sample of Facebook users taken using Facebook survey infrastructure. People were administered a short survey that was taken over the web or via a mobile phone. I explored a lot of different approaches to kind of trying to make our sample of survey respondents perfectly representative of people who use Facebook, and these really didn't matter very much. So, so it doesn't seem like response is a huge problem with the sample that we obtained. I'll show you a little bit more evidence about that in a second. And the uncertainty estimates that I'm going to show you all are coming from the bootstrap. So this is a measure of uncertainty that's based on the sampling uncertainty. So the uncertainty estimates I'll show you are about sampling and not about possible reporting errors or things like that. Okay. Okay, and so this is what the respondents look like. So the survey was administered in Brazil, Colombia, Great Britain, Indonesia, and the United States. On the top row here, we have the number of people who responded to the conversational contact high definition, and on the bottom row, we have the people who responded to the meal high definition. The orange bars are females, and the blue bars are males. And as a kind of note that the sample is a few thousand people in most of the places, except for Great Britain, which was kind of a pilot study, and so that's got a smaller sample of about almost 800 people. And this kind of distribution of these like age sex profiles of the respondents is pretty typical of the age sex profiles of monthly active Facebook users in these countries. So although this doesn't really, this kind of emphasizes the point that this doesn't really look like the populations in these countries, but it does look like the population of Facebook users in these countries. Okay, and so the first thing that we can try to measure is the network size of the people who respond to the survey. So this is the degree in network speak. And so this plot So I'm going to show you kind of one country first, and then I'm going to do this a couple times. I'm going to show you one country first, and then I'm going to show you all the countries together so we can like orient ourselves to the plot here. And so what we can see is that this is the distribution of reported network sizes in Brazil. The conversational contact network is on the top here in blue, and the meal network is on the bottom here in orange. And this vertical line is the average network size. And what you can see is that the average number of people reported in the network is higher for the conversational contact definition than for the meal definition. But if you look carefully, you can see evidence of heaping, which is suggestive of kind of estimation or guessing at responding to this question. And it looks like there may be more heaping with this conversational contact definition than there is with this meal definition. So in terms of the theory that we're looking at, what that sort of is suggestive of is that it is the case that the conversational contact networks are bigger, but that the information reported about the meal network it may be more accurate. And we'll look at that more carefully in a second. Yes?
Just for clarification.
Yes.
The zeros are missing? Nobody reports zero?
No, this is, sorry, that's just the way it's plotted. It's plotted at the 0.0 plus 0.5. So these are the zeros here.
Okay.
So yeah, I agree, it's confused, sorry, yeah, the bars are centered at the halfway mark instead of at the left edge, yeah. But yeah, people could report zero, so, yeah. Okay, so now these are the results for Brazil. So now let's look at the results for all of the countries together. So this is Colombia, Great Britain, Indonesia, the United States, and Brazil. On the top row here we have, again, the conversational contact network. This is the meal network, so then these are the results that we just saw. And if you kind of look at these as a set, it's pretty consistent that the average number of reported connections using this meal definition is smaller than the average number of reported connections using this conversational contact definition. But again, taking this kind of heaping as an informal indicator for the quality of the reports, we see a lot of heaping with this conversational contact reports and not as much heaping in the meal definition. Okay, so that's useful. It seems to be the case that so we do see here directly that the size of the meal networks is smaller on average. The reported meal networks is smaller on average than the conversational contact networks. But what we'd really like is to be able to compare the accuracy of these two different approaches. And so to do this, we're going to come up with what I call internal consistency checks. And the idea here is to come up with two independent ways of estimating the same quantity from these network reports, and then to compare these two different ways of estimating the quantities to one another. Okay? And so if all of the technical conditions that the estimate relies upon are satisfied, we'd expect these two independent estimates to agree up to some sampling noise. And when the conditions aren't satisfied, then we should be able to detect that with these internal consistency checks. And we'll see that sometimes they are and sometimes they aren't. So just to make the example a little more concrete, it must be the case that at the population level, the number of connections from men to women has got to be equal to the number of connections from women to men. And we can estimate these two quantities using the reports that we collected and compare them to each other by taking the difference between them. And we can estimate the quantities using different survey responses. We can use the responses by men to estimate the number of connections from men to women, and we can use the survey responses from women to estimate the number of connections from women to men, and we can compare those two estimates and see how similar they are to each other. So this is like a neat feature of this approach that is a built-in way to sort of assess how well these tie definitions are doing. And it's really useful because, as you'll see, you can kind of use this information to try and improve over time by trying new tie definitions and trying to narrow in on the one that seems to produce the most accurate information. So here's an example of the results of the internal consistency checks from Brazil. On the x-axis here we have, so I should say, this example is about just males reporting females and females reporting males, but we can actually look at something, we can provide more detailed internal consistency checks. We can do these by kind of age group and gender. So for example, we can, we can calculate an internal consistency check for each tie definition and for each age sex group. So what do I mean by that? Well, these are the results for Brazil. This left panel here is females, the right panel is males. As before, the meals are in orange and the conversational contact definition is in blue. And this particular point here shows the estimated number of meals that everybody else reports sharing with young women, minus the estimated number of meals that young women report sharing with everybody who's not a young woman. Okay? So these two quantities are the same by definition at the population level, but we can try to check how much the estimates of these quantities agree empirically. And so in this particular case, the confidence interval, which again only has the sampling uncertainty, includes 0, and so this looks like, as far as we can tell, these reports are reasonably internally consistent. Over here we have an example of a situation where the reports may not be, are not internally consistent, because this is distinguishable from 0 according to the sampling noise. And what this says here is that young men report more connections to everyone else in Brazil than everyone else reports to young men. So yeah, so I think this is actually really interesting socially. Now the challenge is that there's at least 2 reasons why this could be true. So it could be the case that young men are less salient to everybody else in Brazil than the kind of average person, or it could be that young men tend to report one another more than they report everybody else because of this detailed alters way that we're only asking about 3 alters. So I'd love to run another study where we get around that detailed alters condition and are able to actually separately identify the effect of like visibility and homophily and who you include in your network when you report the details. But in any event, for the data that we have here, we can't distinguish between those 2 things. Okay, so these are the results for Brazil. So now we're going to look at the results for all of the countries. So this is an internal consistency check for each age-sex group, both high definitions across all the countries. One second. So this is Brazil, this is Colombia, this is Great Britain, this is Indonesia, this is the US. So the majority of cases, the reports seem to be internally consistent, but there are some exceptions. This is in Brazil, we saw that in the previous slide. Also in Colombia and Indonesia, so there's some evidence that there may be some reporting issues. And this is something that we can try to improve over time in 2 different ways. I think I'm actually going to talk about this more. Yeah, I'm going to talk about this more in a second. But there's 2 different ways we can try to improve over time. The first is we can build models that incorporate the fact that these 2 types of estimates need to be equal. And by incorporating that in a model, we can try to kind of adjust for these reporting problems to some extent. And the second thing is we can iterate through different types of networks that we ask people to report about. And as long as we can tell which network seems to be producing more accurate estimates, we can start to try to converge on networks that have fewer reporting problems. So let me talk a little bit about how we can do that. And, oh wow, okay. Okay, so let me quickly, I'm sorry, I will be happy to answer your question later. Let me kind of really quickly talk about that. So we can estimate the sampling distributions of these internal consistency checks using the bootstrap. And in doing that, we can tell what it looks like the distribution is of how often one network does better or worse than the other. So this is an estimated sampling distribution of the normalized square error in those internal consistency checks for Brazil, comparing the meal and conversational contact definition. In this case, you can see that the majority of the mass of the sampling distribution is in favor of the meal definition being more accurate. We can do this for each Thai definition, and the kind of conclusion is that with the exception of Indonesia, it's pretty clear that the meal definition seems to be providing more accurate estimates. So, so if we did this study again, I would try the meal definition and I would compare it to something else to try and improve over time the type of network that we're asking about. But at least from the evidence that we have here, the meal definition seems to be better. So these internal consistency checks are really powerful. I think this is a big advantage of this approach because it's a way to detect when things have not gone perfectly right and to potentially improve over time the way that the studies are conducted. Just to kind of go quickly, let me show you the estimates. So here we have the 2 Thai definitions again, the conversational contact in blue, the meal definition in orange. This is Indonesia, Brazil, Colombia, the US, and Great Britain. Sampling uncertainty is bigger in Great Britain because the sample is smaller. You can see that these are plausible in the sense that this is like if we looked at GDP or something, this is the order that we would expect to see these data sets in. We don't have gold standard estimates that we can compare against in all of these countries, but in the US and Great Britain we do have a few high quality estimates. And so when we compare to these high quality estimates, we see that our estimates are pretty close, possibly a little bit lower depending on whether you prefer the conversational contact with a meal tie definition.
Dennis, could you read the vertical axis, what these are measuring?
Oh, this is the estimated percent of the adult population that uses the internet.
Thank you.
Sorry, yeah. And again, Indonesia, Brazil, Colombia, the US, Great Britain. The left-hand point in blue is conversational contact, and the right-hand point in orange is the meal definition. And then the points that I just added here are the kind of other estimates that we can compare the survey-based estimates to. These estimates, by the way, are from expensive, full-scale probability samples. So these are examples of the pretty high quality but time-consuming estimates that we'd like to try to improve upon. And let me just kind of talk. So I'll skip this stuff. But I do want to talk about this because I think this is important. So what do we do today? Today we looked at how we can use an online sample to produce an estimate for the share of a population that uses internet adoption. That uses the internet, which seems kind of paradoxical because we only interview people who are on the internet by definition. And our approach was it was fast and inexpensive. It's pretty easy to experiment and change. And we can potentially get very high time resolution estimates because we can conduct these surveys with high frequency. But as I think several of the questions got at, this is an approximate approach, right? This is a way to try and use these networks to make the most out of the sample that we're able to get. If we think about comparing this to a conventional probability sample, this can produce a very high quality estimate, but the conventional probability sample can be very slow and expensive, and so those are both challenges. But critically, the value of having this framework for driving these estimators is that you can identify, you can write down mathematically quantities that you can try to measure on a high quality probability sample that can improve your estimates from the fast internet. So what that means is that the best situation would really combine both an online sample and a conventional probability sample. And you can actually imagine kind of periodically conducting a relatively expensive but high quality conventional probability sample and pairing that with much more frequent but necessarily approximate online samples. And this is kind of the best of both worlds. And actually, if you think about it, this is sort of like a zoomed in version of what we already do with surveys. So if you think about we conduct a census every 10 years, we put a lot of effort in the census becomes the basis for these high quality probability surveys. Well, this is kind of like a different time scale of the same idea, which is that you can conduct a high quality probability survey and then more frequently and cheaply conduct online samples to try and track short-term changes and that sort of thing. Okay, great. So I think maybe I should go to questions, but there's a bunch of other stuff coming, both on the Internet Adoption Project, and then I have several projects that are related, but more demographic and generally that use these in-person samples that I've been talking about. You can check out an early draft of the paper on the PA website from last year, and yeah, thanks.
In the second half
Yeah,
of
I
your talk
apologize
into
for
5 minutes,
Sorry.
which leaves us plenty of time for discussion. Go ahead, Colby.
It wasn't a feature of your talk, but I'm really curious, for selfish reasons.
Yeah.
You have this ability to work within Facebook to deliver the survey.
Yes.
So what do you learn about non-response? So we know there's bias of who's on Facebook, that's the whole point, but what do you learn about non-response
within Facebook?
Within Facebook. How are the people who take surveys on Facebook, just wondering,
Yeah.
how are the people who take surveys on Facebook different from those who are invited and don't?
That is an excellent question. So I talked about how I played with a lot of different ways to try and, there's a huge literature on, because non-response is a problem everywhere.
Everywhere.
Yeah,
No,
so there's a huge literature on how to try to adjust for that. I played with a bunch of different approaches and basically it didn't make any difference to the estimates. And so what that means is that there's not a correlation between the things that I'm measuring here and the probability of inclusion, at least that we could detect from the data that we have. It could depend for other quantities. There may be a correlation for other stuff that you would try to measure with this approach. It's hard to be sure. The other thing is an advantage of so I think you have a lot of experience with ad-driven survey responses, which is great. But the advantage of this approach is that they actually can they can interview a random sample of people, and I'm not sure that it really would be that different to use ads, but it would be an interesting new test. It's an empirical question because the ad mechanism is like an auction, and so it's not clear who the set of people who could be a dude. So it's.
But you also have a lot of information on, theoretically at least, on who saw the ad,
Yeah.
who clicked on it. You have all their Facebook user information in
We,
theory, so I'm
Right, that's right.
about those. But maybe you're finding that, no, it's pretty random.
so based on the, it seems to be pretty random based on the different calibration approaches that I experimented with. We did not extensively explore the linkage to the the goal of this was to really be
On top.
almost a standalone survey. So for example, the age and the gender, that information is self-reported on the survey, it's
Really?
not
Okay.
from the site. So this is really pretty, except for the mechanism for contacting respondents, it's pretty similar to the survey that everyone.
Thanks.
Yeah.
Could you go back to the slide where you had all of the different errors for the different countries? Yeah. Where you had all the countries?
The IC check?
Yes, this one. So it looks like I believe the bars are just error bars, correct?
The bars are what?
Are the bars error bars?
Yes, they're sampling-based error bars. So in other words, the reason that they, the red boxes highlight cases where the difference is bigger than we'd expect just based on sampling experience.
So it looks like older people in general have a lower error than younger people. Is that a trend, or is that just more responses were collected from older people, or?
There were not more responses collected from older people. It's a good question. What's going on with the places where these checks don't indicate that there's not. Basically, the boxes here. I'd really like, so as I was talking about earlier, I'd really like to be able to understand the relative role of this, including the way that we ask people to include 3 of their network members versus the salience of these groups. Because I think the salience of these groups is super interesting just intrinsically, and the extent to which people tend to differentially report others who are similar to themselves. So both of those things could contribute to these errors. And this study, because we asked for information about 3 of the subset of the 3 people on the network, we have that possibility that there's homophily there. In other words, that people report others who are similar to themselves. An alternate design that didn't do that, and therefore remove that concern, might be able to really interpret this as differential social salience, which I think is pretty interesting. But
Could it also be that older people would have smaller networks to report on?
that wouldn't mean that they were not distinguishable from 0 more necessarily.
Okay.
I mean, yeah, but it's a good question. Yeah.
And the reason there are no error bars in the old
The error bars are very small.
is because there are very few old people in your sample? I mean, there are lots more young people than old people in your sample.
Yes, but this is an estimate of the number of connections from old people to everybody else, and from everybody else to old people. Right, so it's not obvious to me that it should be bigger, but yeah. Yes?
So these questions usually ask about contact within a certain time period.
Yeah.
Have you looked at the variation that arises from changing that kind of time horizon?
Well, so that's what the stuff I skipped was talking about. So basically, I think we wanted to ask about the day before, because I think that it's much more probable that people will be able to respond about the day before than about the year before. And so there's basically, we've started to explore that, but that's an area where there's a lot of opportunity to understand better, I think. It's a different dimension from the tie strength, but it's a similar sort of trade-off that may be at play, which is that there's more people in a bigger time frame and that the responses might be less accurate.
Yes.
Hannah.
So multi-layered networks have now become the rage.
Yeah.
Everyone's modeling multi-layered networks.
Yeah.
In principle, you have a multi-layered network if you ask the same respondents about food, about conversation, and about other things. But you haven't discussed the cross-correlations that you get. Is that the next stage?
That is a great question. So in these data, people only answered one network question or the other, but in this study from Hanoi that I didn't talk about in detail, we did ask about more than one network from each person. So we'll be able to start to investigate that to some extent, yeah. So I agree that am I understanding your question right? It's a really promising idea, and yeah, I'm just now getting data that might allow me to look at that, but haven't yet.
I could ask one more question. Sure. Another approach to these kinds of estimates is pinging IP addresses. And
Yeah.
so there's a huge
Yeah.
amount of, you have hundreds of samples, they have hundreds of millions,
Yeah.
billions of responses.
Yeah.
In order to connect what you're doing on an individual level with the world of IP addresses, you would need to know something not only about who is connected to the internet, but are they connected through cell phone, internet cafe, laptop. Is that a direction that you want to go? Because in some ways the consistency problem that's out there in the world is whether the IP pinging is way off, or whether...
I see, because more than one person is affiliated with each
Well,
IP
there are
address.
these different modes, and
Yeah,
yes, you
right.
have more than one person.
Yes, that's a great point.
On the other hand, the IP address expansion data for different countries is enormous and very detailed in time and space. So is there a way in the next stages of this to try to connect with that sampling literature?
That's a great question. I have not thought about that before, but offhand, you could imagine asking additional questions about how the different modes that the respondent uses.
Does your refrigerator have an IP address?
Well, that's true, But, that would be, that's a very natural, Sam.
So, taking the lead from Ken, I'll ask two questions, one small picture, one big picture. So the small picture question, it's actually somewhat big picture, and that's it. I still don't understand how you find out about that case number 5 in the graph.
That
wasn't
great
connected.
question,
So if it turns out that you're finding out about that from a probability sample earlier, then what do we do for places that don't have probability samples? Well, maybe there's some other strategy. And then the second question, so you can answer them both, is you talked about the cost of these expensive studies. And I hear this a lot, but nobody ever talks about the cost of a poorly designed or ineffective or somehow misleading other study. And so I wanted just if you could talk a little bit about that and what really the balance is, because as far as I can tell, that's the real cost we care about.
Those are both great questions. So for the first question, we're using this assumption about the relationship, about meals not being shared on Facebook as a function of Facebook membership to indirectly approximate the visibility of internet users. So what that means is that to the extent that those are, that will include, say, people who report sharing no meals. So that those people go into the average that we estimate, the population level average that we estimate for the number of meals that are shared with other people who are on Facebook. But if those two quantities, if that assumption does not hold, then there will be bias in the estimate. So, but that is something we could measure, as you I think mentioned, with the probability sample. So if we had a probability sample, we'd get to interview everybody in the population, and we could try to understand whether or not actually the difference in the rate at which people who are on Facebook share meals with people on Facebook and people who are on the internet share meals with people on Facebook. And once we know that quantity, we don't have to make that assumption anymore. So
right now we're using the assumption from places where you have it for the places you don't. So those estimates might not quite.
Definitely, they might. That's right. And then I think it's a great point about the thinking about the cost of having an approximate estimate. So the way that we handle this in the paper is we talk a lot about the assumptions, and we also have this whole framework for assessing the sensitivity of the estimates of the different conditions that we make assumptions about. But I think it's a broader, that's actually a really interesting broader question that comes up all the time. I mean, there's a lot of settings where we may not have any data from a place, and we use some model imputed estimate to try and do the best we can, but then that provides maybe the impression that we have more information than we do about that particular place. And so I don't have that's a very deep question that I don't have a ready answer to, but I agree that it's really important to think about
in your defense, no one seems to.
Okay, I think it's a job.
So is this stuff ready to do now, and how much does it cost, and how long does it take to do? So if I want to find out how many people are having Thanksgiving with people from the opposite party, do I just need $200 in 4 hours? Or what do I need
Well,
to
so
do that?
that's a great question. If you want to do this specifically on Facebook, I think the next step is I think this, like how to make estimates when we collect the data, we understand better after this paper, but what Danny was asking about earlier is the key question, which is, as somebody who doesn't get Facebook to run a survey, how would you get respondents who are on Facebook? And one way would be to run ads, which I think Danny talked about earlier in the semester, but it can be hard. There's also online samples though. I mean, there's panels of people online you can pay to get, you pay, I heard as low as $1 per interview, but I'm sure it depends on the.
And then the key thing is I would add a couple of more questions on the people they know in some defined way.
Yeah, to try and adjust for the difference between the people who are in the sample and people who aren't.
Okay.
It's kind of a case, I mean, you have to think through, it takes some thought each time you do it, at least it takes some thought for me each time you do it. So it's not, yeah.
A small question after these big questions.
Okay.
Back to when you were comparing the countries, I guess, but the real, it's not about the countries, it's about age. Why those bars were so small for old. Now, if the true number is very low,
yeah,
then the way you show that visually,
yeah,
it's going to look like it's very accurate, even if it's not very accurate, because the blob is the same size, and the bars are often submerged. And if you instead did
like a relative, like a
yeah,
ratio.
that's what I'm wondering. I don't think it changes anything except the visual interpretation.
It's a good point. I should definitely try that. I mean, the way I found those. So those intervals include 0, or I would have put a box around them.
Yeah.
But yeah, well, a different approach would be to look at like the ratio of the two estimates.
Yeah, that's what I was thinking.
Ratio or something. Yeah, that's a great point. Yeah, thank you.
Time for one more question.
Okay.
Is it? If there's somebody
Somebody new?
Somebody new?
Somebody new?
Oh, I'm sorry. So I'm wondering, this seems like it would lend itself to counts of people, but not necessarily asking about like the people who you can't survey's opinions on things or their thoughts or anything like that.
That's right. So this is not a cure-all. This is one approach to trying to use an online sample to learn about an offline sample. But and there's a lot of things that it could work for, but there's definitely things that wouldn't work for. The key question is really, do you think that people will know whatever you're interested in about other people that they're connected to? So if you think that people will know something about that, then there may be a way to use this. But if not, if you, for example, don't think that people very accurately know one another's opinions, then you need to try it.
Thank you, Dennis.